All right, everyone online, if you can hear me, please say something.
Yes.
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 All right, thank you. Okay, let's get started. So day 2 of our math class. This is the first day we'll actually work on some math stuff. The stuff we're going to look at today, it's not especially hard. Again, we're just kind of, maybe it's been a long time since you've done a math class and you just need some time to start the math part of your brain working again. And also, again, if you've never done a math class in English before, we're getting used to being able to talk about this stuff. So still a bit of a slow start here. Supposed to go to the next slide. Oh, that works. But this does not go right clicking. All right, whatever. These are the various terms that we talked about last time. I think most of these are not too tricky, but maybe some of these exponent ones, not everyone was familiar with those. So the more general form a to the exponent b. And then I think variable, most people knew, but constant for coefficient. Some kind of specialized terms that we'll be needing. Also, these ones, lots of people knew ways to talk about this, but the standard forms, again, less than and greater than. So useful to know. Okay, today we'll yeah, it works as a mouse though. I can click on anything else like a mouse, but just on the screen, it's not. Again, the other classroom, the other TV, that's the identical one as this, it works perfectly fine, but just not as a separate. I don't know. All right, well, I'll do this. So a little more just kind of course setup details, some administrative stuff. The assignment, the tech setup, and the survey, if you plan to attend online or in person, please have that done by the end of today. I think most people have done that, but still not everyone. Most people are on the classroom page, so just a few stragglers. If you do need it, if you haven't joined the Google Classroom page yet, this is the code here, or just look at the Smart LMS and there's a link right there at the top that I posted. All right. The math diagnostic, no, I already told your class about this. It was the other class that met on Monday, right? Okay. So I think maybe I didn't mention, later this week, I will email out details probably Monday evening next week for anyone who missed doing that test because link problems or whatever, we'll address it then. For those of you who've never really used Zoom much before, just a little hot tip here. Anytime you get a Zoom link for something, that number at the end, that is the meeting ID. So if for some reason the link itself is not working, just when you open Zoom, you can type in a meeting ID, just that number will work and that will get you in the meetings. All right, so some new stuff to talk about. Workshops and homework. So with this class, I'm going to do workshops. It's just extra practice questions. We'll be doing that every Thursday afternoon from 4 o'clock to 6 o'clock. That's when there are no first semester classes. If you're not a first semester student, it's impossible to find a time that works for everyone, but it does work for most people. So recordings of those will go online. So it's just extra practice questions. The lectures, I'll kind of explain the material and the concepts, and then the workshop, it's just, okay, let's do a whole bunch of practice with that. If you're going to come to them, then you should be registering through that My SolBridge platform. First semester students, I think, are fairly familiar with this. If not, the Adapt class that you're going to have tomorrow will explain all about this for you. No. This time is for the workshops for this class. Your Adapt class is always on Fridays. Really? Okay, maybe the schedule. What time is it? Okay. When I chose this time, there were no conflicts. So maybe the schedule changed a bit. Yeah, from what I knew, the Adapt classes were just like from 10 a.m. to 5 p.m. It's the same professor just doing them all day Friday. Okay. Maybe I'll move this time to be in the evenings then. All right. Okay, like the schedule has gone through many changes before the start of the term. When I looked, there were no conflicts. But okay. I can't change the time for today, but maybe for the future weeks, I'll try to find a better time for everyone. So with the Adapt class, you are required to attend like X number of workshops, not just for this class, but any of those tutoring lab workshops. You're required to attend some certain number. So we have to check attendance. So I would only mark you as coming to this workshop if you're actually there. So if you have a class conflict, obviously that won't work. But there's going to be one every week. We will have lots of these. So sorry about this week, but we'll get that. Sorry? Shouldn't. You register for this? Okay. Yeah, I did see a number of people. You can just leave it. Like I have to do attendance for the workshops. So people who don't come. All right. Well, that's another thing for me to get figured out this afternoon. So workshops. The other part is homework. So two types. We'll have preview questions, which I kind of talked about last time. These will be every week by Sunday. It will be just a preview of what we are going to do that week, just like a very simple question on the topic that we will be covering for that week. So due by 8 p.m. on Sundays. And those, I'll talk more about how the grading for that will work at the end of today's class. The other part is those will be very simple questions. The other part is the more formal, like long homework, more standard style homework. We'll have one of those every 2 weeks. So this is kind of a basic sense of what our schedule will look like. So we'll have a lecture 1, a lecture 2, and then a workshop on that material. Sorry, you guys are the other class. Nope. Got to switch these out. So Tuesday, Thursday class, and then some other time we'll figure out the workshop. And then there'll be a preview question for the next week, and then 2 lectures, workshop, and then a homework assignment sort of from the previous 2 weeks combined, that material together. And then we repeat that for weeks 3 and 4 and 5 and 6, and et cetera. So that's the basic schedule. Whenever everything that goes up, all the preview assignments, they'll say very clearly what the deadline and everything is. You don't need to memorize this, but just to help you understand what the structure will be. Okay, does anyone have questions about any of this administrative stuff? Okay. Someone asked, is it for the first semesters? I didn't see exactly when this question was asked, but the workshops are available for anyone to join. The My SolBridge platform also, anyone can join that. Every student got an email like 2 days ago about how to join that and how that works. The current plan is, or there has to be at least hybrid because there are lots of people online. The one I have for today, I'm planning to do it entirely online. Yeah, we still have to get a room figured out because we don't know how many people are coming, what size of room do we need, et cetera. Okay, so workshops online for today. If that changes, I will let you know. Okay, so workshops are not mandatory. If we see that there are some students who are like really struggling in the class, then I might say, okay, you should be like, I'll kind of push certain people to say, okay, you kind of need to come to these workshops. So I know you're getting the extra help you need. Workshops, again, it's the attendance for that. It factors into the adapt class. It's not attendance for this class. So there's no like, you can't like miss one of these lectures and then make it up with the workshop. That's a separate thing. So the content is relating to this class, but not the grading directly in any way. Okay, if you have other questions, go ahead and ask them, write them in the chat. I will see them a bit later. Yeah, check if anyone has registered. No. Yes. I understand how like older professors who aren't familiar with all this tech stuff, how they get very confused about running all of this. I have 3 different monitors, all this different audio systems, and like 5 different ways to register all happening at the same time. Okay, so last time, just quickly again, business world, a good business, a well-run business runs on numbers, and the numbers have to be interpreted and understood in order to be able to make good decisions. All of that is based or happens using math. So that's why we are doing all of this. All right, so the first half of the term is basically straight lines and all sorts of applications of straight lines and systems of equations involving straight lines, matrices, which are linear. So that's the first half. That should take us up to the midterm. Okay, so today again, just some simple, not especially complex algebra stuff, just to get you to remember this stuff again if it's been a while since you've done a math class. So these are the questions that we will work on today. If you're online, please take a screenshot of this because I'm going to put you in breakout rooms in a little bit. But for everyone, about 5 minutes, 8 minutes, we'll see how much time you need. Just try to work through these questions. And then second, I will put people in groups to sort of share their answers to these, and partly to see if you can share ideas with each other, but then also to force you to talk about these things in English because we need that practice too. And then we will go through all of them. All right, so take some time now, take out some paper, try to solve each of these. Are you typing the math? Okay, search here. Try to use your own memory first. I'll explain all the rules, but I want you to try first on your own. Okay, it's been about 8 minutes. I see one or two people who look like they're finished, but most people are still working. So now I'm going to ask you to talk with people who are sitting near you, share your answers. If you're confused, like what is the thing you're supposed to do, whatever. So talk about these. If you're online, I'm going to put you all into breakout rooms. You'll have about 5 minutes to talk about this, and then we'll all come back and work through, okay? So 5 minutes, please talk with some partners about all the answers. You gotta keep your mask on, please. Thank you.
What number? Where? Yeah, father. Yeah.
Okay, that's enough time to work. So let's actually talk about all of our answers here. So people were still talking about them, still working on them. So it seems like we still have some parts here, some questions that will be maybe still confusing to some people. I figured out how to just swipe right and left. Right? Tap doesn't work, but swipe. The other TV in the other room is just tap. This one is swipe. I have no idea why. Okay. So first, yeah. Start with the first one here. So we're trying to solve. We have an x and a y, two variables. It would be nice to know what those variables are. So what's the first thing we should do? Okay, so we're doing this. So this is. So this is expanding. So we're expanding and then nope. There. So at the bottom of the screen, if you're in the classroom, it's a little hard to see, but you can kind of see it at the bottom there. This is just the basic pattern. So if we have something outside brackets multiplied by something in brackets, we expand to go one way, or we factor to go the other way and find the common element and pull that common element out. But in this case, we're expanding here. So so right down here, what you see at the bottom. So we're expanding because we multiply the a by both, and factoring means we are taking out the common element from each. So factoring out a from both of those. So expand and factor. All right, 2xy plus 4x, okay, and then here minus 2yx minus 4y. And hopefully we all recognize or remember that 2xy and yeah, so yx. Those are the same thing. We just changed the order of multiplication. That's not a big deal. Which part? This and this? Okay. Usually we would call this, we'd say that they cancel out. Yeah, so cancel each other out. Or eliminate. So the 2xy terms just cancel each other out. They're gone. So we have 4x minus 4y. And then this is pretty simple. We just simplify and we get x is equal to y. So maybe we were expecting a number, so we didn't get a number. So x equals y, what does this actually mean? What number can x be or should x be? In which part? That's the step. Like factoring out the 2x from these two terms? Yeah, that's what the first step was. Yeah, that's going backwards. So here we have x equals y. What does that actually mean? What number can x be or should x be? 1 or 0? Only those two choices? Anything. Okay. So x could be absolutely anything as long as y is that same anything. That's the only restriction. Other than that, we could put any numbers we want in there. All right. Move this over a little bit. The next one. Here we have some fractions, so adding and subtracting fractions. Let's see if we remember what the rule here is. What's the first thing I want to do? Multiply by 6. Just the whole thing by 6 and by 6. Okay, so that would give me 6x over 18 minus 6x over 12. Is that helping? No.
Can I try?
Okay, go ahead.
as we know, the general divider for that is 6, and then we divide 6 by 3, and then it will be 2x.
Okay, so we're looking for, yeah, you got the right idea. So we're looking to have the same number on the bottom of all the fractions. That's the goal here. So we're not multiplying by 6, but we want to turn these into 6. So something over 6 minus something over 6 equals something over 6. And then what did we do to the bottom number to get that? Well, we multiply this by 2, we multiply this by 3, 2,
and then by 2.
So we just have to do the same thing to the top of the fraction. So 2x
minus 3x 6 4
over 6. Okay.
And then as we have the same kind of divider, now we can skip the 6 and then we can solve as if it's an inequality equation.
All right. So we have the same. This fancy name here. The bottom of a fraction we call a denominator. That's a kind of fancy word. I'm just going to say bottom of the fraction and top of the fraction, but if you want the fancy word, there you go. So it's the same number on the bottom. So now we can multiply everything by 6 to eliminate it. So now we just get 2x minus 3x equals 4. And now just the part is pretty easy. Negative x equals 4. Yeah. Questions? No, we're good. Okay. So just adding and subtracting fractions there. Yeah. So the general rule I have at the bottom here. These little things on the bottom, these are screenshots from the website that I linked to on our classroom page, at algebrarules.com, which I think is a very funny just name for a website. Just someone thought that would be very useful and they made that website, but it is useful. So the first 10 on there are just linear relationships, and that's good review for all the stuff we'll be talking about for the first half of the semester. So if there's anything there that looks a little confusing to you, go back and review those things. They have good examples on that site. Also, our textbook for this course has lots more examples and explanations of all that stuff. All right, next ones. So multiplying and dividing with fractions. See if we remember how to do these ones. Okay, so on the left here, I have 25 over x equals 1. How can I simplify it? Sure. Okay. So why does this one go to the bottom? Yeah, so I want to show all the steps clearly and not skip anything. Okay, so let's write that. So 25 over x. So divided by, here we have x over 1. Okay, good. So that's the idea here. If we have two fractions that are being divided by each other, then yes, so upside down. This fancy term there is invert. So just flip upside down. So invert and multiply in this case. So we flip over the second fraction, change this to multiplication, 25 over x times 1 over x equals 1. Okay. 25 over x 1. All right. 25 squared, take a square root. Okay, so square root of each side. and then plus minus 5. So this, write this out, clarity. So if we think from kind of this step going into x squared, if we had 5 and positive 5 squared gives us 25, but negative 5 squared also gives us 25. So when we see this part, we have no way of knowing which one it is. The x value could be either one of those two. Lots of practical cases, like in a business context, you would never have a negative value of like production or something. So we just kind of conveniently forget that one, but in the math world, anything can happen. So both of these can be there. All right, the one on the right, same process basically. So we'll write this out. So 5q over 2 divided by 1 over p plus 2. Yeah. So we'll do the invert and multiply again just for clarity, and then it should be pretty clear. Okay. And so from this stage, it's pretty clear we have kind of the same thing on the top and the bottom. These can be canceled out very cleanly. And 5q equals 20, so q equals 4. So someone asked me in the chat, well, do we have to solve for both of p and q or just q? Well, when we do this, p disappears. So p could be anything. So that's what this is saying. Or almost anything. So q must be equal to 4. Let's just give a little bit of clarity here. What about p? But when we did this, p canceled out. So the same thing would happen. So p can be almost anything except one number. Y minus 2. Okay, so if we look here, so if p was -2, we would have a division by 0 problem, but any other number will work. So if we're being very careful, here, q must be equal to 4, and q must be equal to 4. P must not be equal to -2, but it could be anything else. That's kind of the full, very careful solution here. Okay. Right, yes. There. The rule here, the one on the left is just a shorter version of the full one. So on the right, bottom right here, two fractions being divided, you invert and multiply. And then when you multiply across the tops and the bottoms, then basically the very top one, the A, and the very bottom one, the D, go on the top of the fraction. And then the two middle ones are going to go on the bottom. That's the basic pattern. If you forget why, or you don't believe me that the invert and multiply thing works, then just stay after class. I'll show you a little proof of that, or you can find it online pretty easily. All right, so 2 or 4 more here. These ones should go a little quicker. All right. Okay. All right, so what can we do to solve this? Okay, so we could expand. If we see this, we do understand it means x minus 2 times x minus 2 equals 4. And then we do our expanding that times that and that and that times that. Does that help us get an answer for the x value?
What if we just square root each side?
What if we
Okay.
take roots, square
All right,
roots?
we do have a formula, but I think there's a shorter, okay, so let's do the shorter version here. So what's the easier thing to do?
Square roots, taking the
Square is
square root.
squared 2.
So square root of each side, and what will I have on the right?
2.
Plus minus 2.
Okay, plus or minus 2, because square root of 4, it could be a positive 2 or negative 2. Now, what do we have to do to solve for x?
We have to bring -2 to the unknown. I mean, x should be left, and then 2 plus 2, because when it goes to another side, it will be changed to the opposite thing. I mean, opposite
Okay,
number.
neither person is telling me exactly what to do. What did you say?
We bring -2
Module?
to the right side of the equation.
Like, okay. That's these bars like this. Okay. This is not something we're going to use very much in this class. This is absolute value. That one, there's a different term, modular division or modulus. That's a different thing for division. So the vertical lines here, absolute value. Okay, so the easiest way to think about this is, so when we see this plus minus 2, it's not some weird special version of 2. It just means there are 2 versions happening at the same time. So either x minus 2 is equal to positive 2, or the other version, x minus 2 is equal to negative 2. And we just consider both of them and work these out. At this point, it's pretty easy. X equals 4, or x is equal to 0. So both of those 2 values will satisfy this original equation. So the plus minus just means 2 things going on at the same time. All right. On the right here. The one on the right, so now we don't have an equal sign. We have this thing, this less than sign. How do we treat this less than sign? Yeah, so we just do the same thing that we do for the equal signs. It's not anything especially different, except for a small number of special cases. So 25. So 25 is less than 10x, and then loop the 10 over. So we'll get 2.5 less than x. And of course, by convention, usually we write the variable on the left side. So what would it be?
Is greater.
Greater than. Yeah.
Greater than. So 2.5. So just here, the sign has to flip directions. If you're moving everything from one side to the other side, flipping sides, sign also flips directions. The other situation is where, and we didn't do it here because I wrote on the first slide, we assume that x is greater than 0. But if we are multiplying or dividing by a negative number, then also we have to flip the direction of the sign from less than to greater than. So if this were, say, negative 10, and we had negative 10, and then we divide by negative 10 on both sides, then the sign needs to flip directions to still keep the relationship true. So those are the only 2 real special things with less than or greater than signs. Otherwise, they work the same as an equal sign. Okay, and last 2. These, yeah, the algebra happening here is not very hard, but some students just get confused about the style of the question. So solve for R. This is saying we want to take this formula here, which you may recognize from geometry. We want to turn this into R equals something. So we want R to be alone on one side and everything else to be on the other side. So what is our first step here? Okay, so I'll do these. Yes, we'll do those just kind of one at a time so we can see what's happening. So first, let's say the 1/3. Let's move that. So 3v equals pi r squared h, and then we can divide by pi and h. So 3v over pi h equals r squared, and then just square root of each side here. V over pi h. Okay, sort of yes, but what is this a formula for?
Volume of a cone.
Okay, so right, so volume of a cone. Cone. Okay, so if we have the height and we have the radius, then we can calculate the volume. But when we talk about a circle doesn't have a negative radius. It's always positive. There's no like direction to it. So in just thinking about square roots, then yes, technically positive, negative, but we never talk about negatives and for a radius, so we just ignore that part and we just kind of pretend that isn't there. So if we're, again, this formula for this particular context, we just keep the positive sides here. And on the right side, one more here. So first, what is this a formula for? Okay, temperature. So changing temperature from Celsius or from Fahrenheit, the American one, over to Celsius, what the rest of the world uses. Or sorry, not the American one, the old one, but now most countries use Celsius. So changing from Fahrenheit to Celsius, what would our process be? What's our first step?
Move 5/9 to the left, so it becomes 9/5c.
So we could expand, but that's not necessary here. We can just divide by 5/9 or multiply by 9/5. So 9/5c equals f minus 32. And then
Move -32 to the left, so it becomes 9/5c plus 32 equals to f.
so 9/5c plus 32 equals f. And then this formula will convert from Celsius to Fahrenheit. So again, very simple algebra happening here, but let's just talk a little bit more about strategy for these kinds of questions, because some people get pretty confused with these. Right here. So order of operations. If you have some big long math equation, you can't just do whatever parts in whatever order. There's a particular order you should work in. I'm sure each of your languages have some clever way of remembering this. In English, it is BEDMAS, BEDMAS, so brackets, exponents, division and multiplication in the order that they appear, and then addition and subtraction in the order that they appear. So that's the standard way of doing this. When we're doing these kinds, or sorry, just I'm sure we all remember, but we work down. We start at the top, brackets first, and then work our way down. when we are doing these kinds of problems to isolate one variable, you can kind of see that we're working the other way. We start at the bottom and work our way up. So let's say, I'll change the question here and kind of break the formula. Let's say we had something like this with a +5 on the outside here. So if we're working backward here, then this +5, that's the furthest thing away from the F. That's the easiest thing to move. So we would do, okay, C -5. And then that would be gone. And then we would do this 5/9. So that would turn into 9/5. C -5. And 32. So we kind of work our way up, division, multiplication, done, no exponents. Okay, now we're to the brackets. Then we get rid of the brackets, and now we repeat this whole process for inside the brackets, like this. Got back to like the 32 plus 32 equals. So again, isolating variables, we just kind of work backward, work up, opposite order of the standard order of operations. So I hope that idea isn't too complex for people. I've seen a lot of students where when we do interest stuff in this class, we'll have some formulas like this. And instead of just saying, okay, I want R, let me just quick rearrange, they try to memorize like 3 or 4 different versions of the same formula. That's a lot more work, more likely to make mistakes. So just some simple algebra rearranging will help you take care of these kinds of situations. If you need a little more strategy for these, just imagine that these were numbers. So instead of V, and I know pi is a number, let's pretend it's a variable, and H here. If this were just something like 5 = 1/3 times, instead of pi, let's just say 2 r squared. Instead of H, let's say, I don't know, 7. If I gave you this and asked you to solve for R, you probably have no problems with it. So just the same thing that you would do, kind of multiply out, move everything to the left side. Even if they're variables or letters, that same process works. So being able to rearrange even when everything is variables, that's a very useful thing to be able to do in math. My major when I was a student was math, and very quickly numbers disappear. Like after your first year math classes, everything is just variables, and this kind of rearranging is just like basically all we did in class. So as we move up with math or get to higher level things, then this becomes a pretty essential skill. Okay. Backward. Okay. All right. Those are the questions. Does anyone have remaining questions about any kind of math concepts that we saw there? No, we're all kind of remembering this stuff well. It's coming back. Okay, good. All right. The last thing we'll talk about is just preview of the linear algebra stuff we'll do, just the vocabulary here. And in our next class, we'll actually review the concepts themselves, the math behind them. So first, just points, lines, equations, just remembering or learning how to talk about these things. So we have a graph here, a very simple graph with a line. Let's just talk about all the parts. What is an axis?
The X and Y axis.
Okay, so the X and Y axis, so X axis here, y-axis here. So the main lines, the x-axis shows us all the places where y is equal to 0, and the y-axis shows us all the places where x is equal to 0. X, axis, y, axis. The plural version of this, just in case you need it, is axes, not axes. So we have an x and a y. If we were to label one of these as an independent variable and the other one as the dependent variable, in most cases, which is which? Okay, so x is usually the independent variable, y is the dependent variable. If we had a graph of time and distance, like please mute yourself, whoever is not. Yang Sakju, please leave your microphone off if you are not speaking. We all heard the background noise there.
Yes, sir.
Microphone off, please. If you are not asking a question, keep your microphone off.
Okay.
Yes, we all hear the background noise from where you are. Okay. So if we had a graph of, say, speed, so it would have distance and time as our independent variable on x, and then our distance as the dependent variable on y, or of maybe units sold of something, and then, okay, what is our profits? So the profit depends on how many things we sell. So units sold are Q value. We'll actually see a lot of those graphs that will go on the horizontal value, and then dollars would go on the vertical for profit. So it doesn't need to be this way, but almost every graph you see, this is the standard way of doing it. Okay, points. A point is a point. That's not very hard, but just the coordinates are these number pairs here. So all of these are coordinates, like 6, 2. So coordinate because it is a pair there. So just the numbers that tell us the locations. So this point here, 6, 2. What does the 6 represent?
X.
Okay.
X.
So the x value, because it's 6 steps over here, and then the y because up by 2. So that's the x, that's the y. All right, the other, our sort of a special point here is the origin. So at point 0, 0, we talk about that a lot. So we have a fancy name for it, the origin. Okay. Line is a line. The equation of a line, we talked about equations last time, so we can see that here, y equals 0.5 x minus 1. So for this line, what are the intercepts? Can you tell me the values for the intercepts?
2 and -1.
2 and -1, good. So here and here. So we have an x intercept and a y intercept. So the intercepts are the places where a line is crossing the one of the axes. So this is the x-intercept, because this is where our line crosses the x-axis, and then this is the y-intercept, because it's where the line crosses the y-axis. So people get confused between this and the word intersection, which look very similar and come from the same root word, but they have different meanings in the math world. Yes. So intersection is this, where, sorry, I should do a different color. Is this where two just regular lines are crossing each other? That is an intersection, but intercept is specifically the special case where a line is crossing one of the axes. That is our. So intercept is a special kind of intersection with a different name for it. So important to keep those two things clear. Intercepts are very useful to talk about, especially with linear relationships. So we'll be using those words a lot. Okay, and last one, I find that a lot of students have kind of forget what slope is or what that concept is. So let's say, let's pretend I've never taken a math class before. Explain to me what slope is, the concept, in just the simplest terms possible.
Rise over run.
Okay, rise over run. Can you give me a little more detail? What's a rise? What's a run?
A rise is basically it's like the change in the y-axis, the y coordinates, and the run is for the x-axis. Yeah, something like that.
Okay, so it's a ratio between the changes in the y values and the changes in the x values. So if I were to write one word for this, it would be sort of the steepness of a line. How steep is it? Does it go up a little bit? Does it go up very slowly? Does it go up very quickly? Does it go down perhaps? So if we just take any 2 points on the line, here and here, for example, if I take one step with x, how much do we go up by y? So this equation, the slope here, 0.5, is telling us if x goes up by 1, goes right by 1, then y goes up by 1/2, and that's our slope. So a slope of 2 would look like this. That up correctly. So like this, because when x goes up by 1, then our y value is going up by 2. So that's the basic concept, steepness. It's not an angle. Angles are another way of talking about directions of lines. But when we're graphing like this, we don't use angles. We use this concept of slope. So we'll talk more about some more math stuff behind that next time, but that's just the basic idea. Okay, that's the vocabulary stuff. Any questions about what's here? All right. Wait. Yeah. Okay, so the preview question is this for our next class. I'll post this on our classroom page immediately after this class. So I want you to figure out these 4 things. So first, what are the coordinates of points A and B? What is the equation of line f of x? So this line here, what's the equation? What's the distance between these 2 points? So this shortest distance between A and B. And if you remember how to do it, what is the shortest distance between point A and then this line f of x? Okay, so this preview, what you're going to do is on the classroom page, you're just going to work these out on your own, then just type your answer. These preview questions, you do not need to show me full solutions, just what you think the final answer is, and then we'll talk about it in class and we'll see how we can solve these. Yes, this is homework by Sunday, 8 p.m. Grading on this is going to be completion grading. So just means you need to make a serious attempt. If you make a good try, but you have a mistake, you'll still receive full points. If you just give me some like random number that I know you didn't try or you submit nothing, then you get 0 for it. Okay, but a serious attempt with some mistakes, you'll still get full points for it. The other homework that we do once every 2 weeks, that will be a more standard style. You'll lose points if there's mistakes on it. But this preview, I haven't shown you how to do this yet. So just give it your best shot. And then in class, we'll actually see how to do it. So typed, that's maybe a weird thing, but it's not hard to write this stuff out. Square roots, which you may need for this question. Or let's see if we know. Does anyone know if I want to write x squared, but I'm on a computer? How do I write x squared? Okay, so it's this little, this thing. This is a caret, a fancy name for that. You will never need to know that word in English, but just in case you want to know. So that, so it looks like this. So that is squared, and if you need a square root, lots of options for square roots. If you are doing like programming or using a spreadsheet, this is the command for a square root, just sqrt for square root. Or of course, if we remember and understand that square roots or roots are just fractional exponents. So
Half.
this, x to the exponent 1/2, that means the same thing. Okay, so that's a little annoying to type out, I know, but you can handle it. Or just search Google square root symbol and then copy paste that thing in. That's another way to do it. Okay, so details about all of that will be on the classroom page when this goes up. So those 4 things by end of Sunday. All right, so wrapping up. We talked about that last time. So workshop today at 4 o'clock, which time doesn't work for you guys. We'll get that fixed. Preview question Sunday. That tech setup assignment where you tell me your Google Classroom display name and the email address and stuff you use, and survey about online or in-person Discord. Just please finish that by the end of today so I can organize my student list and everything on the weekend. Any questions, anyone? No, good. All right, if you have questions online, people, just hang around and I'll talk with you. Otherwise, enjoy your day. I'll see you on Tuesday.